let's get the show on the road. Very well then. So welcome everyone to Secure Microservices with MicroProfile and Keycloak in 30 minutes or less, if hopefully time gives. So I already did a short introduction, so we're going to skip that and allow me to do a bit of shameless self-promotion of Payara. So as I mentioned, we are part of the Eclipse Foundation, and we contribute to both Jakarta and MicroProfile. Those are the working groups that are responsible for making sure that these standard technologies are, let's say, evolve in the interest of both the Java community and companies everywhere. So we have a set of engineers that work not only on implementing these technologies, but in contributing in discussions and progressing them along. And we represent our customers in general as well, and the voices of the community when they want to be here about how these technologies are to be implemented. For example, as you may be aware, there are a lot of discussions regarding AI nowadays. So our company and the Eclipse Foundation are discussing on implementing a standard to integrate AI technologies that are permeating Java in general as one of the other technologies that we want to implement in the future. So we're also member of the project management committee of Jakarta. So we have a lot of say in there. And again, this is just for representing our customers and the general voice of the community. So our main product, it's the Payara platform. It's represented in two variants. The first one is Payara Server Enterprise. And this is the standard, let's say, application middleware server that we sell to our customers and that we use in order to allow them to deploy applications, design either the traditional monoliths or microservices and deploy them and organize and coordinate them in a centralized manner. Or if they're developing in a more modern environment, there is Payara Micro, which is ideally for running containerized Jakarta microservices deployments on either cloud native deployments, or if they're using Kubernetes, if they're using Terraform or any other modern orchestration tools, it is very friendly to those technologies as well. So, well, the promotion over, let's get on to the talk. So, security is hard in general. One of the main tenets of security is correctly managing user identities. Whenever you implement a business application nowadays, one of the first things that you have to think is, okay, I have to manage the identity of the users. If I'm responsible for collecting the data, how do I do that securely? How do I rest easy in the fact that, okay, I am collecting this information and I'm storing it somewhere. So ideally, how do I apply these security patterns without reinventing the wheel? Because again, implementing a login box or implementing redirection from a secure to a non-secure side, implementing session management, all of that has been done all over the place in many technology frameworks and programming languages. So the idea is how to apply that which has been defined for these other frameworks in a, let's say, reasonable and efficient way without delaying the implementation of your application. And that is risk management in a sense. So you have to secure your microservices with minimal risks, because at the end of the day, your responsibility is to do this without affecting the performance of your application. Specifically, if your application runs in a high available environment, like a Kubernetes deployment, okay, how do I do this responsibly and efficiently without affecting the response time and whatever SLAs you are promising your customers? So one of the things that I recommend my customers when they are implementing these solutions is to use a user identity management platform. And there are many platforms in the industry. There are both cloud native platforms, those are that are offer as a service, like for example, Auth0 or Okta, or there are on-premise implementations like Forgerock and Keycloak, which we are going to talk about. So Keycloak is a product by Red Hat. It is very well implemented user identity management platform that allows you to securely and manage how user identity information is collected across application universes. It also allows you to connect third-party applications and first-party applications from your environment to this user identity management platform and securely transfer information in a standard way. Why standard? Because Keycloak is OpenID Connect compatible. And I'm not going to go too much into detail, but this is the cornerstone of what we use for our integration. Keycloak also allows you to do deconfiguration of separate tenants or data universes. You can, and they are known as realms. You can have multiple realms of data that separates data from one universe into the other, preventing collision or preventing information from being collected in these universes. It also has a single sign-on integration for those organizations that say, oh, we do not want to trouble our users with remembering passwords or with using separate sets of credentials for multiple applications. We just simply want one application, a set of credentials, or just simply want to integrate all of these applications in a seamless way because we are running in a controlled environment and that allows us to do so. And at the end of the day, because Keycloak is a software tool or a service that you can maintain on yourself, you can just simply configure it and run it on premises or on a cloud environment using Docker or whatever. Maintenance is on you. So you don't have to be worried about that data being breached if, for example, you are given or you are relying on a third-party service. So you hear that every year, some company that is responsible for security gets breached and the reputation is tarnished. And of course, you as the end user are also not only worried, but also responsible for any potential user information being leaked. So yes, you still have to worry about making sure that all of this information is secure online. But at the very end, your responsibility or that responsibility falls on you and how strong and how secure are you making this environment. So OpenID Connect, it's a set of standards. It's maintained by the Cloud Native Software Foundation, and it allows any service and third-party applications to talk to our repository of user information in a secure way, mainly using HTTP, and establish a communication flow where, okay, you are logging or you are attempting to use an application and you need to authenticate a user identity. In that case, that user identity verification is done by what is known as the IDP provider. And this IDP provider will then redirect the flow of that authentication back to the application that is authenticating that user in order to allow them to continue using what is known as a bearer token. These bearer tokens are used to authenticate that user and say, this is the identity of that user, and this user has a specific access to a set of services implemented in your infrastructure. So every service will have to use that information in order to validate if that is what they want to do. So in a sense, the OpenID Connect workflow, it's a 7-step workflow where in the summary of what I said, it just simply starts with navigating to a website or a web application and finishing with information that is secure for a specific period of time. And afterwards, you have to start the process again. So how to use this to secure microservices? So microservices usually rely on a stateless communication. You can implement stateful communication with microservices, specifically protocols like gRPC or WebSockets or the binary protocols that allow you to exchange information and maintain a session per the user. But in general, they are stateless. So in that case, you are responsible for implementing a security mechanism that should validate each request separately. Whenever you're calling a microservice, every time that you're making a call, you have to ensure that, okay, here is the bearer token that will allow the service to verify if this user is not only authentic, but if they have access to call the service within the parameters that you have specified. And if not, okay, you will return either a 401, this user is not authenticated, or a 403, this user doesn't have access to that service. And not only that, but those services have to propagate that security context. Okay, once they verify that the user can do what they can do, then okay, if the service needs to call all the services, that information is propagated across the flow or the trace, as is known in microservices development. So JWT, JSON Web Tokens, which is another web standard that allows you to exchange this information securely, is what you think. So JSON Web Tokens, it's just and a standard, a token-based authentication and authorization standard that is compatible with OpenID Connect. All of these tokens that are generated are specified as such on the OpenID Connect standard. They are based on a specific RFC 7519 that contains all of the details and the schema of these specific tokens and how they need to be generated and validated. They rely on a set of standard claims that allow you to verify, okay, this user identity, these are the attributes of that identity, and these are the abilities or access or specific permissions that this user has on the context of that specific service or application. So, as I mentioned, OpenID Connect is an interoperable authentication protocol. It is ideal for REST and JSON services or microservices in general. It was built on top of the Google OAuth 2 protocol that was created a while back, that was used as the foundation for OpenID Connect, and it has expanded ever since. At the moment, it's at version 2, and it's ever growing with more and more use cases that allow them to go beyond what is the traditional communication flow across microservices. It is very easy to use. Most frameworks and multiple programming languages have binding APIs or have some sort of API to interact with any sort of service or tool that talks in OpenID Connect. So like Keycloak, as I will show. So Eclipse MicroProfile, it's a technology that was implemented originally in order to come with the shortcomings of what was known as the old Java Enterprise Edition. And it was created as a way to implement cloud-oriented microservices. The idea was that, okay, there are some things that Java EE or Java Enterprise Edition cannot do in the context of enterprise Java. If you go to the other side of the aisle, you saw what Spring was doing. These guys were like, okay, we need to implement some of these API bindings or these shortcomings that this technology has in order to catch up. So MicroProfile was born as a way to short that gap, and in that way, align Jakarta with modern development. And one of these developments that were implemented was JWT, JWT propagation. So this is a set of APIs that allow any Java enterprise application to just simply, with a set of annotations and minimal code, connect that application service to an identity provider that talks OpenID Connect, in this case, Keycloak, and allow automatically for the application's runtime to do some role-based access control. That means, okay, this specific service can only be called by users that have this role and only this role. And that role will allow to automatically set the runtime's response to either, as I mentioned, 403 forbidden if the user doesn't have the correct permissions to call a service, or just simply execute the service and carry on as normal. To do this, the JWT, in this case, the token, is validated in a three-step scenario when, as in the call's identity is first introspected. That means, okay, let me grab that identity and see what it contains. Then I delegate the validation of that identity to my identity provider, which in this case is Keycloak. And then once I validate that that user is who they say they are, then I verify that they have access to the resources. And it has some leeway. You can flexibly configure how that validation is done, but the defaults are very much okay for most of the scenarios. 90% of what you want to do, it's covered by what the default settings are. So in order to showcase all of this, let me showcase this quick demo that you can find on my GitHub account, Microservices, Keycloak demo. So what you are seeing here is the project open on IntelliJ. So it is maybe a multi-module project. It contains 2 modules, one for each microservice. And in this case, let me quickly showcase what this microservice demo is contained. It contains 2 microservice application. It is used mainly for configuring conference talks. Let's say you are preparing for an event and you want to set talks, and you have session talks and speakers that are hosting this or are presenting these talks in this case. So you have 2 microservices, one for organizing and managing speakers and another for organizing and managing sessions. And to bind all of these microservices, you have a single page application. In this case, for this example, I'm using a very traditional Angular application. I know that Angular is no longer super popular as it was in the past, but this showcases exactly what we want to do. So for this universe of data, we have three groups. Each one of these groups contains a set of roles. The administrator, which can do everything. They can create talks, view register speakers, add new speakers, etc. The speakers, which can only do these three things. Attendees, which are technically okay. In this case, this is an anonymous user that wants to attend. Well, not an anonymous user in case. This is a regular flexible user that wants to attend these sessions, and they just simply can log in into the platform and say, I want to attend this session, but nothing else. And well, in this case, it's just these three roles. So coming back to the code, what we have in here is the Maven project that contains the two modules for my microservices. And how are these services implemented? Well, these are traditional Jakarta REST services endpoints. If I go, for example, to the speaker service, you will see that it contains very basic set of API endpoints. This speaker resource allows me to just simply get the data of a speaker, get all of the information for all speakers, add a new speaker, accept any speaker. If they have submitted a talk, the administrator can just simply accept that speaker. And in order to set how MicroProfile JWT will allow role-based access control on these resources is by using the add roles allow annotation. With this annotation, I'm just simply setting, okay, this role can call all of the methods defined on this resource, and all of these specific roles also are allowed to override that definition overall. So technically, you can control how you're setting access to this code, but you're not telling it how. That is not the responsibility of the implementer or the developer. That is the responsibility of the runtime. How are you configuring this application with MicroProfile JWT? Well, you do that by using the add login config annotation. This is a very simple annotation that has an authentication method, and you set that to mp-jwt. Doing this, you're just simply telling your application, okay, this application will get data using MicroProfile JWT tokens. Well, in this case, JSON Web Tokens, but the runtime will be MicroProfile JWT. So there are only two things. Yeah, you need to tell your application, or in this case, your service, when you are connecting this to MicroProfile JWT runtime. In this case, as I mentioned, there is an identity provider in the back that is validating this request. In order to validate this request, the runtime needs a key generated by the specific identity provider. So I have my identity provider already running. If you want to run this on the demo, there is a configuration in here to run Keycloak as a Docker container. Let me set that up. So, sorry, this one. So, this one, yes. So you can see here that Keycloak is running as a Docker container. You can access it on this port 80808080, which I have remapped. So by default, I am using an admin user. Oh, sorry, let me try this. There we go. And in this case, I have configured a realm named conference that will be used by my application. If I go to conference, you can see that I have 3 users that I have already configured. In these cases, these users all have configured one of the roles that I have defined in this case. And in this case, roles and groups are defined by Keycloak in this way. A group is just an aggregation of roles. And if, for example, I go to the admin group, you can see that it is mapped to all of the roles that you saw on the slide. The same for the attendee role, the same for the speaker role. And in this case, you can configure groups to be assigned to specific users. And again, all of this will be the responsibility of the user maintainers. In this case, this would be the users that are responsible for administrating this data on behalf of the applications, or you can expand this administration by using the Keycloak API as well. It has a proprietary API, and it also has an OpenID Connect management compatible API that allows any application to just simply outsource all of this management if they want. So lastly, Keycloak has this cool thing where it's already compatible with MicroProfile. If I go to client scopes, you can see that these are the data that allows Keycloak to export identity information on the token that you will see in a bit. So there is this specific scope named MicroProfile JWT that is not assigned by default. You have to turn it on. But in this realm, I have already set it as default. Otherwise, it would be as optional. And what this scope does is that it has a mapper that will create two claims on that token. One claim called UPN. This is obligatory by MicroProfile standards. It has to be in there. And this claim will map the username to this UPN claim, which is an acronym for use preferred name. In this case, you can set it up whatever you want. In this case, Keycloak defaults that claim to the username of that identity. And it also has a groups claim that will automatically map the groups to the groups claim for that token. This is, again, not by design, because identity manipulation in Keycloak and in OpenID Connect doesn't use groups by default. It relies on roles. MicroProfile decided to use groups. So in this case, you have to map this. Or if you're using Keycloak, it already does it for you. So how does this work? So on your services, in this case, you need the services to talk to Keycloak and validate that information. There are multiple ways to do this, but MicroProfile JWT, what you can do is use either a properties file. You can use this either, again, this is not recommended on production, but this is just to showcase this. You need these two properties, mp.jwt verify public key location, and this needs to point out to a public key in either JWK or JWKS formats. These are standards of OpenID Connect. And this is automatically provided you by Keycloak. If you go to -realms, -conference, -protocol, -OpenID Connect, you will get this key automatically. In fact, I can do this, and I can go over here and paste that. Play nice, please. Again, there we go. Here is a standard JSON format, which contains the key in certificate format, as in Open 509 certificates, that this will be used by the MicroProfile JWT runtime to verify the tokens. These tokens are assigned using a private key, using an asymmetric key encryption. So they need to be verified because, of course, one of the tenets of authentication is that the integrity of that token could be tampered while it's being transferred. So you only need to do that and specify an issuer who generated this token. And in this case, the issuer, the entity that generates this token is Keycloak. So I need just simply to point it out to the location of my Keycloak running locally to -realms -conference, which is the realm that I'm using. So if you were using this on your application and you create a specific application realm or realm scope for Keycloak, then you would use its name over here. That's it. That's everything your microservice needs to use in order to configure this to Keycloak. So I have, as I mentioned, a JavaScript application that runs Angular, and it automatically will connect it to Keycloak when it starts. How this is done, it's not too complicated because, again, Keycloak has a lot of bindings. It has a JavaScript API, and someone was kind enough to create an Angular set of components that use that API in order to wrap all of that nicely. So I can just simply go here to the app module. And on the configuration of the module, I have some settings. In particular, I have a Keycloak config object that points out to my URL where Keycloak is running. I need a client ID, which is conference-web. This is an application that I need to register on Keycloak. So if I go over here to clients, you will see that conference-web is in here, and it has been configured to accept requests incoming from this web application. This is a standard of OpenID Connect. If you're using another OpenID Connect compatible implementation, or if you're using a service online, you will need mostly a redirect URI. That means when the authentication is done, where to redirect the application that generated that request. And you also need to validate and specifically logout URL. What happens when that user is logging out of the session and invalidating the token where they are redirected into? If these URLs are not registered, Keycloak and your OpenID Connect provider will deny communication because they have to be validated first. That's everything that you need to do. On your application, you just simply set it, okay, I want to use this client ID and this realm because you can have multiple applications on a specific realm. That's everything Keycloak needs to do. So to run this, what I'm doing is just simply, let me optimize this. I'm initializing Keycloak by calling the Keycloak service. This is a standard service that is provided by those Angular components that I mentioned. It will accept that configuration, and I want it to set it up with this settings. When it's loaded, I want it to check single sign-on if it's already signed or there is a user sign. I don't want them to re-sign because, again, for the practicality of the scenario. And I was just also to check silently that you are redirecting that single sign-on. And I wanted to directly to this asset silent check SSO HTML. This is a bit of a workaround to do this on Angular. On other frameworks, on other technologies, you can do it in a different manner. That's about it. So when all of this is configured, how does it look? So I go to my application. So in this case, you can see that I'm not logged in. So let us log in. You'll see that my application has redirected me to Realms Conference Protocol OpenID Connect, and it's authenticating me on behalf of conference-web, and I am redirecting to the URL or URI that I configured on my application. So let's use one of the users I mentioned, in this case, Carol Beta, which at the moment I forgot what they are. They should be, I think, let's see, they are a speaker. So in this case, this user can do some things and they cannot do other things. So what they can do, so as a speaker, they can register themselves as speaker. So let's say, for example, that this person works for Payara Services Limited. Let's save, and that person can register as speaker. But if that person wants to register a new session, let's say, for example, Microservices 101 on a venue or name Ocarina. Let's say that they are running that session on the 17th of November, and this lasts 30 minutes. So if I hit save in here, you see that that person is not authorized to create new sessions. And what they will get is a 403 on the console. So if I open this over here, and if I open the console and reattempt to do this again, so say Microservices 101, Ocarina, on the data that I mentioned. So 30 minutes, and if I hit save, you will see that you are getting a 403 forbidden in that case, because that user is not allowed to do that. Again, if you were designing the user, this URL, this application for the real world, you wouldn't allow him to do this on the UI. You will just simply block the button or not render that button, but just for the sake of purpose and showcasing, I'm showing you what you can do. So how this looks. In that case, I have created a profile here page that allows you to see two things. Number one is the access token. It says ID token, and you should say access token. This is the JWT in an encoded form that you can use. You can see these tokens easily with just simply copying them and pasting them on jwt.io, which allows you to quickly encode the information. So the tokens, it's separated into a header, a payload, and a signature. And on the payload, you can see the information of their identity information. The type of the token, in this case, is a better token, what application they are configured to run, what is the access that they have, what is the expiration time of this token, because every token has a validity of limited time, and a lot of other additional information. So all of that is present, and the user has the ability to see this information. And again, this token, it's available not for end users, but it's available for services to be validated for them. What you have seen on the code is very simple. It's just very easy code to plug in both my client application to Keycloak and my microservices to do the validation. Everything else is done by the runtime. So it is absolutely very easy to do. So in that case, coming back to close this session. So Keycloak allows you to delegate user management and authentication. In that case, you don't have to implement anything. You don't have to worry about if the user requires a password of a specific length of characters, or if the user needs to reset the password every specific number of times, or if the user is using their socials in order to authenticate their information. All of that can be configured on Keycloak. It simplifies the authentication workflows and removes security challenges for microservices. My microservice is not responsible for handling security. In a sense, it's just responsible for securely integrating with the identity provider. And it centralizes user management. If you're implementing microservices, if you implemented, let's say, a big application that requires 20 microservices, instead of implementing a separate microservice that will handle user authentication and authorization, you just simply use an already provided platform that does that for you. And MicroProfile JWT allows you to plug in an existing, well, okay, it says here Okta, but it should be Keycloak realm via configuration properties. It allows you not to worry about token validation algorithms and allows you to focus on setting role constraints to existing services. As I showed you, just with a simple annotation, just tell specifically what services are allowed to be called by what specific roles. Thank you.